last year. If you're in pre-algebra, you're going to see a lot of similar things and a lot of language that we're working at. I squished about a week's worth of lessons that we would take last year into about one lesson. You'll notice that a lot of the next like 2 weeks or so is going to just be similar content that you saw in 7th grade, but just at a faster pace. If you weren't in my class, you'll get the hang of it in a few days probably, but just for today, kind of roll with me and just make notes very, very detailed of what each of these parts of the problem we are annotating so you can hang on and get to the next set of problems that will need those skills for. Example 1. Read it for me, please, Colby.
Suppose Corey and his friend Walter go to the movie. Each of their tickets cost the same amount, and they share a frozen yogurt that costs $5.50. The total amount they spend is $19.90. How can you write an equation that describes the situation?
When you get to word problems, it is really important to slow down and make sure you annotate before you get to the final answer and actually any work in the first place. The first thing that you're looking at when you're scanning these is something that would make an equal sign. Normally the word is tells you that you're going to have an equal sign, and I'm scanning for the word is. It is right here. Box the word is. I kind of crossed it out with my circle of the words. And that word is where you're going to start with. If you see the word is, you know you're working with an equation. You're going to have something equaling another thing. And the word total tells you the operation involved in the relationship is addition. You're adding something up, you're getting the total. It could also be subtraction in some cases, so don't be robotic and always put addition, but more often than not, it'll be addition. Then look at the numbers. I'm going to circle all the numbers and give the information that they have. First off, they say the cost is $5.50 and they buy 1 frozen yogurt. So the numerical information is the numbers. $5.50 is 1 frozen yogurt. That's the first number they give me. What other number do they give me, Silent Hands? Wyatt. And what does that represent? That's the total they spent. Let's see. We want to make an unknown quantity, which is my variable. You were saying x, Wyatt. What does the x represent? And we don't know the price of the ticket. Do they get 1 or 2 tickets? They get 2. So let's put just an X or a T for ticket. I'll put X because T looks like a plus sign. So X is the cost of 1 ticket. So there's a lot going on. I slowed down enough to kind of jot down this stuff. I'm going to mainly do in my head after we take notes, but I'm going to do it while I look at the word problem. Next, write a verbal description of the variable. We already chose a name for the variable. They want to use C for cost. We used X. Either way it would work. Let's change it to C. C makes more sense. The verbal description would be twice the cost of 1 ticket plus the cost of 1 frozen yogurt would equal $19.90. That's what I'm doing in my head as I'm kind of processing this, and the equation would be, skip this, we don't need that box. If it's twice the 1 ticket, so 2 times the 1 ticket, plus the cost of frozen yogurt. What was the cost of my frozen yogurt, Kylie? And did I know the cost of the ticket, Kylie? No, that's why it was my variable. But both of those, if I add them together, should equal what's my total, Vienna? Cool. We're going to just pause on that, make the equation, and circle it. We don't need to solve it for some of these. The first half of your bronze will just say create an equation. That's a skill that I want you guys to develop today. Solving it will come later, but we want to make sure we're solid just with piecing all this info together. Okay, so that's a lot of like step-by-step stuff. If that's in your head just like way too much to write down, have no fear. We're gonna do a lot of this just with annotation. I don't need you to actually write down like all of these blanks every time. It's gonna happen when you annotate. Read example 2 for me, Lexi, Aaron, and Alice. Okay, take about 30 seconds right now to box any keywords. You're looking for words that make addition or multiplication or subtraction or division. I see one of them right here. Then underline the thing that you're trying to find. And I'm going to circle my numbers. What is one thing I do not know after we annotate? Ooh, I have one more thing that I didn't annotate. If you have something else that I did not catch, can you raise your hand? What would I add to this, Felix? Right here. Okay. What else, Elliot? Beautiful. That is going to mean equal signs, so something equals something else. Yeah, Wyatt.
So I solved it, and it's like.
Let's pause because I want to actually just get to the equation. Do you have an equation I could start working with?
Yeah.
Okay, what's your equation going to start with on the left side?
So I don't know if this is how you want the equation to be, but I did 320, or well, I took away the 5 because it's and 5, so I did 315 divided by 3 plus 5.
So you have about step 2 is what you're working with. We're going to start with step 1. Step 1, I'm going to look at this equation that they give me. Alice scored twice the difference of Aaron's score in 5. We're going to set that up, but when I look at that, there's 2 different things I don't know. I don't know Alice's score, I don't know Aaron's score. So let's make one variable be Alice's score. Let's make that A. And I don't want to make another A, so let's just do maybe R for Aaron. So we're going to set up 2 things that we don't know. If Alice's score is twice the difference of Aaron's score in 5, give me an equation that I can use for my first equation. Alice's score is twice the difference of Aaron's score and 5. Alice's score is twice the difference of Aaron's score and 5. I start with my equal sign. What's on the left of this, Tanner? A is Alice's score, and they say it is something else. What's the equation on the right? Twice the difference, Aaron's score and 5. Twice the difference, Aaron's score and 5. Give me your thoughts. Just throw something out. Sarah, what would you make that equation look like? Twice the difference of Aaron's score and 5. Close. So there's something happening with difference of. When you have twice the difference, you're going to end up having to put something in parentheses because you have 2 times this whole thing. It's 2 times the difference of Aaron's score, which is R, and 5. So put R in the parentheses, subtract 5. There's your first equation. Twice the difference of Aaron's score and 5. 2 times R minus 5. There's your first equation. And would be, Usually it's plus because the difference is there. Difference always means subtract. So it's the difference of this and that. The difference of 5 and 2 would be 3. The difference of 7 and 4 would be 3.
So did she have an extra 5 or
I don't know. Let's set up with algebra and see if we can kind of work our way through that. The second equation, I still need to go to this part over here. I do not know. Let's go with pink. The sum is what they tell me, but I don't know Aaron's score. I have an equation for Alice's score. If they say sum, you're thinking addition. If you see is, you're thinking equals. Find each student's bowling score, so we're going to use the information they have for the second one to set this thing up. It is equal to 320. Do I know Alice's score yet? I don't have a number, but do I have an equation for Alice's score? What is it, Porter? What would the equation for Alice's score be? Yeah, so let's plug that in. And then if you add Alice's score with Aaron's score, you would get 320. Why wouldn't I just make an equation that was Alice plus Aaron equaling 320? Why can't I just do that? Get ready to turn and talk to your partner. Why do I have to use this equation to solve but not that one? There's something specific when I try to solve that does not work when I try the left method. Turn and talk odds, you're first. Go.
It's twice 1. So 2 and 1. That's 3. So you take away 5, you divide it by 3, you have 1 or 5. And then you multiply by 2. No, you can't do
5, 4, 3, 2, 1. Silent hand, why can't I solve it using the left equation, but I can solve using the right? Wyatt.
Thank you. Because it doesn't have the minus 5.
You're close. That's part of it, but I need a little bit more. Tell me more about that. What's next to the minus 5?
The R.
And when we solve equations, what are we solving for?
The A.
We're solving for a variable.
Yep.
So either A or R. Can I solve for anything specifically in this equation?
I think you can. Well, you have to by itself, no, but if you add one.
Correct. So by itself, I can't solve this thing. I need the variable to be only R or only A. Because this equation has only R, I can go ahead and solve it. So once we get to this part, you needed to set up an equation that equaled A. We plugged in this thing to make it 2R minus 5 plus R. Let's solve from here. Solving this starts with the distributive property. You get 2R minus 10. We're 3 steps away. Combine your R's. 2R plus 1R is 3R. Add the 10 to both sides. 3R equals 330. Is that 110 when you divide? So your R value is equal to 110. What did you just find, Elliot? You found Aaron's score because... Did we? Yeah, because R equals Aaron's score. So we can put here that Aaron's score is 310. Uh, 110. But I don't know Alice's score. I need both because that's what it's asking me to find. To find Alice's score, I'm going to use some space here. I'm kind of running out of room. You can find a better spot probably on your paper. Alice's score is over here. It says that A equals 2 times Aaron's minus 5. So let's use that to get Alice. Alice equals 2 times Aaron's score is 110 minus 5. You end up with 2 times 105. And Alice ultimately won because her score is 2 times 105. That would be 210. I think I know what you're going to say, Jordan. Did I make a blunder?
Yeah, you made, because 2 times 110 plus 5 does not equal 2. 110 times 2 plus 5 does not equal 2.
What?
Are you plugging in A over here?
If you look at the scores, Alice's score is twice the difference of Aaron's and 5. If you do that math again, though, with the values we were given, it doesn't equal what it says it does. So something's wrong.
I'm solving this and it works for me. Are you looking at this one? Are you looking at the 210 here? 220 minus 10 is 210, plus 110 is 320. So both of my equations are working out. Yeah.
Why don't you just subtract 110?
From what?
From 320. Yeah, there's no minus.
Where did you find that in the equation? Did they give you anything in the equation, or you could do that? I'm gonna pause you because I pause 3, 2, 1. So Elliot, I want to track the board. I showed you the algebraic way using the 2 equations, but Elliot, you have an alternate method. What's your alternate method? And where do you see that in the equation? Okay. Okay. If I didn't know Alice's score was 220, could I have done that? Or 320? If I didn't know Alice's score was 220, could I have done that? Alice's score is 210. If I didn't know Alice's score was 210, could I have done that?
You get Alice's score. I got Alice's score by subtracting 110 from 320.
Right.
I had all that information.
Right.
It's not
You
like
could say all of this. Really
So if you
justify
can do that, if you can do that when they tell you that Alice's score is like 110 less than, if you have that information in here, that's fine. And if you can point that out in the word problem, that's okay too. So if you're able to look at the word problem and say that and point it out to me, I'm totally fine with it. When you get to word problems, there's a lot of different ways to find the answer. I'm giving you the 2 equations that I want you to start with. As long as you have the equations on your paper, you'll get full credit. And then you can work with like anything kind of like a puzzle, what Elliot's doing and a few others, Wyatt and Sarah. You can work around with that information and just show me what it is on your paper. Yeah. It was 210 and 110. Jordan, I'm gonna go to your paper because I proved it on mine, but some things a little different because it did work on mine. Yeah.
Okay, so I did this in like 10 seconds.
I'm gonna pause you because I don't care about the answer. I care about the equation. Go ahead. Thank you.
No.
Example 3, Janine has job offers at 2 companies. One company offers a starting salary of $28,000 with a raise of $3,000 each year. Underline $28,000. There's your starting point. A raise of $3,000 each year. Underline $3,000. That's another key part. You can also circle the numbers if that works better for you. The other company offers a starting salary of $36,000 with a raise of $2,000 each year. $36,000 underline or circle, $2,000 each year. Looking at 28,000 with a raise of 3,000 each year, there's one number that is going to be the starting point and the other number changes. 28,000 versus 3,000, what is the number that is going to change, Colby? 28,000 is your starting and a raise of 3,000 each year. Tell me more, Colby. I think you're on the right track.
You add 3 to 28.
Great. So 28,000 is going to be changing. It's going to be going up. So one company we'll call A, company 1. And let's make an equation for A. A's salary is going to be 28,000 as your starting point. That number does not multiply by anything. That starts at 28,000. But then there's a raise, and Colby said it's going to increase by 3,000 for every single year. Let's make X the year. Sure. Then they give you another company, company 2. We'll say it's B, sure. And company B is a little bit different. They give you a starting salary that is higher, but something else changes. What is the thing that's changing in company B's salary, Sarah? Instead of 3,000, even though it starts out a little bit higher, it doesn't add as much each year. So your X is going to be another thing we don't know. Let's jot down what X means. X is equal to the number of years. And X is what we're trying to find. The A and the B are going to just represent the totals. So we could represent A and B with a total. A and B is just the total amount that they earn. We want to know how many years they're going to pay exactly the same. If we want to know how they'll pay exactly the same, we want to know when those two are going to equal exactly each other. So we want these numbers to equal exactly the same total. We're going to make T equaling total salary or total money. And these things have to equal each other. So let's set this up. If they equal each other, they're going to be the same salary. We're going to take both equations and equal them to each other. I need more room. Let's go down here. That's company A, and it should equal company B. What is the only variable left in my equation at this point, Andrew? What's the only unknown? X is the only thing that I have left, and that's the exact thing I'm looking for. In my problem, I want to find the number of years. Let's solve. I'm going to subtract by 2,000 on both sides. And I want to get X by itself. I'm going to move 28,000 to the right. 1,000x should equal 8,000. And your number of years would be 8. So at 8 years, you will make exactly the same amounts. You're not going to make more or less. If you work 8 years, you're going to eventually make the same amounts. Wyatt?
I don't know if I have like some flawed math over here, but it doesn't look like that on my paper. Like,
So
I wrote it out. I did